Hey, welcome to The Explainer. Today, we're going to pull back the curtain on the technology that makes your code editor feel, well, almost psychic. That little bit of magic that seems to know exactly what you're thinking.
You know that feeling, right? You type a variable, hit the dot, and boom, a whole list of suggestions pops up. Or you hold down Command and click a function name, and you're instantly teleported right to its definition. Yeah, that's not magic. It's actually this brilliant, high-speed system working behind the scenes, and we're going to break down its two key parts.
All right, to really wrap our heads around this, let's use a simple analogy. Just imagine that your entire codebase is this massive sprawling library filled with thousands of books. Now here's the really important part of this whole library story. You, the developer, you don't actually walk over to the card catalog and start digging through drawers. I mean, can you imagine? That'd be super slow and tedious. Instead, you just ask the librarian for help, and they use that perfectly organized catalog to find exactly what you need in a flash.
Okay, so let's talk about this card catalog, the abstract syntax tree, or AST for short. This is where the real secret sauce is. See, when a computer looks at your code, it doesn't see text and words like we do. It sees logic. It takes your code and transforms it into a structured, tree-like set of data. And that is the AST. It's a map of the relationships in your code, and it couldn't care less about your tabs, spaces, or comments.
Okay, check this out. This is where you can see what I mean by code as data. A super simple line of code like x equals 1 plus 2 gets broken down into this logical hierarchy. At the very top, you've got an assignment node. Underneath that, it has two kids, a variable node for x and a binary expression for the plus sign. And that expression has its own children, the two literal numbers. This, right here, is how a compiler or a linter sees your code, not as a string of characters, but as this queryable tree of information.
All right, so that's the map. Now let's talk about our librarian, the Language Server Protocol, or LSP. The LSP isn't a static thing like the AST. It's an active running process. Its whole job is to be the helpful go-between, connecting your editor to all those powerful tools that can actually read and understand the AST. And here's the thing you gotta get. The LSP is what makes all that raw data from the AST actually useful to you. It's basically an API for your editor. Your editor asks the language server a question like, hey, what methods does this object have? And the LSP goes, figures it out by looking at the AST, and then sends a clean answer back. And that answer is what becomes the tooltip you see, or the red squiggly line under a bug.
So this table just lays it all out, right? On one side, you have the AST. It's static, it's a data structure, it's the what. It represents the pure logic of your code. On the other side, you have the LSP. It's a dynamic running service. It's the how you get features in your editor. And you'll notice that last row, portability. The AST is specific to a language compiler, but the LSP, that's a standard. And that's exactly why you can get awesome TypeScript support no matter which editor you love. VS Code, Vim, you name it.
Okay, so we've got the map and we've got the guide. How do they actually talk to each other? Well, while you're coding, they're in this constant, super fast conversation. Let's walk through what happens in that split second when you ask for an auto-completion. So here's the play-by-play. You're coding along, you type my var, and then a dot. Boom! That single dot is the signal. Your editor immediately fires off a request to the language server. The language server catches it, instantly creates an AST of your current file, and then walks through that tree to find everything it knows about my var. It bundles up that list, sends it back, and your editor shows you that drop-down menu. And this whole round trip, we're talking milliseconds. It's so fast it feels seamless, like your editor is reading your mind.
Okay, so this is all really cool, right? It explains how your editor works, but, and this is a big but, understanding this is way, way bigger than just appreciating some neat features. Once you truly get what an AST is, you unlock a completely different level of power.
This is the mental shift that changes everything. The AST isn't just some temporary thing the editor uses and then throws away. It is your code, just represented as structured data. It's your code's fundamental DNA. And because it's data, we can do things with it. We can query it, analyze it, and most importantly, we can programmatically manipulate it. We can operate on the very structure of our programs.
And this is where we get into some seriously powerful stuff. Because it's structured data, we can essentially pull out a template from it. Think about it. You can write a tool that looks at the AST for a function and extracts its core blueprint, separating the pure logic from the specific variable names or values you happen to use. And once you have those templates, those blueprints, the sky's the limit. You can build tools that automatically regenerate and update your code. Imagine writing a script that scans your entire codebase, thousands of files, finds every instance of an old component, and programmatically adds a new required prop to all of them. That's not science fiction. That's large-scale code generation, and it's all possible because the AST allows you to treat your code as what it really is, data you can operate on.
So, we've gone pretty deep here. Why does any of this actually matter to you as a developer in your day-to-day work? What's the big takeaway?
Because this knowledge, this is the dividing line. It's what separates someone who just uses their tools from someone who can actually build them. It's a total game changer. Suddenly, you're not just hoping someone else built the linter rule you need, you can write it yourself. You can automate massive, tedious refactoring jobs that would take weeks to do by hand. You've basically unlocked a new level of power and control over your code base.
So I'll leave you with a final thought and a challenge. Go find an online AST explorer. There are a bunch of them out there. Paste in a piece of your own code, maybe a function you're proud of. See what it really looks like to the machine. I promise you, once you see your code's DNA, you will never look at it the same way again.